Section 2.2, Families of Functions. We need to sketch each function. Briefly describe the transformation from the parent functions. Let's go. So over on the far left, we have the parent functions for an absolute value. Again, if you can't see the function, we're just simply going to plug in numbers and then graph them. So if you plug in 0, you get 0. So we know our function starts here. If I plug in both negative and positive 1, it starts to go up to 1. So our parent function for an absolute value will look like this. What we want to now realize is if we change outside of the absolute value, so for the g of x we have -4 and for the h of x we have +1. What you will notice is if we plug in 0, we get 0, but then we get -4. So our answer says 0, -4 is a point. So we're going to go down 1, 2, 3, 4, and then our function basically stays the same. So we get the same properties as the parent function, except for now it is shifted down 4. Okay, if we say +1, we know that instead of going down 4, we're going to go up 1. So we're up to 1, and then it keeps the same properties. So if we plugged in -2, absolute value -2 is 2. 2 plus 1 is 3. So we would go over 2, -2, and then up to 3. Okay, so this is a up 1. General form, if you notice, if we add or subtract something on the outside, that gives us a vertical translation or some type of shift. So what we want to do is, if we take the f of x function, okay, one thing we could say is if we add or subtract k, okay, if we add k, it goes up that many units. If it's subtraction or subtracting k, it goes down k units. So then number 2 says, well, what if we change inside of the parentheses? So for the f of x, we get x -4, and for the k of x, we get x plus 1. Parent function doesn't change, so it still stays at the origin. And if you remember this point right here, which I'm circling really big, that's called the vertex. And that's the main point that we want to focus on and figure out, well, where is that going? Plug this into a calculator, we can check its graph. I think the easier thing to do too is to look at the x -4 and ask yourself, what makes that 0? So if we take this and we say x -4 equals 0, x equals 4, that's going to tell us where our point is. So if we plug in 4, we get 0, so 4, 0 is a point. So we go over 1, 2, 3, 4, we put a point, and then now we draw the function graph that goes that way. So now we have, instead of a shift up or down, now we've taken a shift right 4. The next one, if we go x plus 1 equals 0, x equals -1. -1 is to the left of the graph, so we're going to go -1, put a point, and then our graph still stays up. Okay, so now we've gone left 1. Going back to number 2, really look inside the absolute value sign and ask yourself, okay, what makes that 0? What can I plug in for x to make it 0? Okay, that kind of tells you which way to go. So this is our horizontal translation. If we change the f of x, so we make it x plus h, that is a right k units, and if it's an x minus h, it's a left k units. Now we want to describe the translation from parent function of an x squared. If you remember, this is a parabola, or a 0, 0 starts. So we know 0, 0 starts, and then if I go positive and -1, we go up to 1. Positive and -1, we go up to 1. If you go positive and -2, now it becomes 4. So 1, 2, 3, 4, and then we get almost our U-shape graph. So there's our parent function. This again is still the vertex. So we ask ourselves, okay, if we take that x squared and we add 3, so just taking the vertex, if we take 0, 0, if we plug in 0, you get 0 squared is 0 plus 3. Now it becomes 3. So it is shifted up 3 and still has the same U shape. So this is a up 3. If we change, instead of on the outside, if we actually change the x that's being squared, okay, what do we get? Well, let's plug in 0. 0 minus 5 is -5. Negative 5 squared is 25. So now we would have to go 0 on the x and then way up to 25. So another way of looking at this is, what makes that 0? And the answer is 5. So we're going to go to 1, 2, 3, 4, 5, positive 5. And then that's where the vertex begins. So this is a shift right 5. Okay. We can also make it a little bit more complicated. We can do both. We can change what's inside the function, or inside being squared, and we can change the outside. So let's start with the inside. Where's the vertex going to be? Well, if we ask ourselves, what makes the x plus 3 0? We're going to say negative 3. Well, negative 3 is to the left, so we're going to go left, negative 3, and then we have to go down 2. So 1, 2. There's our new vertex. We know it's a parabola, so the parabola goes up this way. So now we've had a left 3 and a down 2. Number 3 is the square root function. If you plug in 0, you get 0. So we know it starts to the 0. Very hard without a calculator to take, say, the square root of 2. So try and do, right now, do perfect squares. Square root of 1 is 1. So we go over 1, up 1. And the next one would be 4 over 4 up 2. You'll get a square root function like this. So now we want to figure out, well, what if we don't add anything on the outside of the square root function? We don't add or subtract anything on the inside, but we make it a negative. Okay? What you'll get is what's called a reflection. It now, instead of going, let's make this a dotted line. So here's our original parent function. Okay? Now what we get is it reflects about this x-axis. So now you get the function down here. Okay, so the green is the new reflection. What we get is a reflection across the x-axis. So basically it's y equals negative f of x. So what we're going to do is we want to describe the transformation from the parent function and then include a sketch of the new function. Okay, so we have f of x equals the absolute value of x. We know that that's our parent function for absolute value. So we draw a V shape. Draw a V shape. There's our parent function. Okay. G of x. What's going to happen if we put a negative on the outside? Well, we're not adding or subtracting anything on the outside, so it's not a vertical translation. We're not changing the x on the inside, so it's not going horizontal, but we are doing negative, so that is your reflection. So now instead of it being a V, it goes downward V here. So what we're getting is a reflection across, again, the x-axis. Last one, so B, we have j of x equals negative absolute value of x plus 2. There's two things you see, hopefully. You see one is a negative, and that tells us the reflection, but we changed the inside of the absolute value sign, and if you remember, that's the horizontal shift. Nothing going up and down. So if we ask ourselves, what makes this 0? X plus 2 equals 0. X equals negative 2. So we're going to go over to negative 2, and then we know that the graph, instead of opening up, it's going to open down. So we draw our V. We have left 2 and a reflection across the x-axis. A little bit more complicated now. Square root. Well, we know we have the square root, okay, and it was like that half of a sideways parabola. But let's just plug in numbers. So try and think of something that can give you positive. So let's try 0. 0 squared is 0. Square root of 16 is 4. Go from 0 and then up to 4. Okay. The other thing, if we go, let's say we go to try and square something. In other words, if we put in 1, 16 minus 1 is going to give you the square root of 15. That's an ugly decimal. So we're going to try and get something that gets us a perfect square that we can take a square root of. 4 square root of 16. 16 minus 16 is 0. That makes it easy. So we get 4, 0. And if we actually did that, if you remember, we square any negative. So let's go negative 4 square root of 16. 16 minus 16. So we get this function here. So if we take that parent function, a number 4, and we apply g of x in the middle, well, we didn't change what's underneath the the radical sign, but we did put a 2. So we're basically doubling, or we're making everything twice as tall. So the zeros are still going to stay the same at this 4 and here, but now we're going to take that 4 and go 2 times 4 and get 8. In other words, right here, this was at 0, 4. Now we're going to multiply that by 2 because it's 2 times as tall. We're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And now you have a stretched parabola. And then the last one is the same absolute value, but now we're taking 1/2 or 1/4. So 1/2, oops, sorry. That's a half. So what's basically going to happen is to take our original function and we're going to make it half as tall. So half of 4 is 2. So it still touches there, go up to 1, 2 this time. And it's kind of a smushed parabola. So what we did just now, instead of going up and down, left and right, or a reflection, we do vertical stretch and compression. So y equals our a times our function. A, if a is greater than that 1, so 2, 3, 4, 5, what we're going to do is it's a vertical stretch. Okay. If a is, now you can't go negative, so don't look at a negative, but from 0 to 1, okay, so 0 is greater than or equal to a is greater than or equal to 1, then it's a vertical compression, meaning we squish it, which basically says if it's a decimal or a fraction. Hit pause, do A and B yourself, check back in about a minute. Alright, let's check and see what you see. We know that this is an absolute value sign, so it's V shape. It's not moving up or down. It's not moving left or right, nothing on there. But we did multiply 1/4 or a 0.25. So this is a compression because it's less than 1. So we can say vertical compression by a factor of 0.25 or 1/4. Okay. B. Hopefully you see the 2 things. Actually 3. Excuse me. We see the -5. That means it's going to go down 5. There's nothing inside that changed the x, but we did multiply by -3. The negative tells you it's going to be, yes, you guessed it, a reflection, and it's going to be a stretch. So the first one we could say, okay, it's a reflection across the x-axis. It's a vertical stretch by 3, and it went vertical down 5. Putting all this together, kind of the definitions, there are 2 types of translations you should know. Okay, shifts, in other words, there's vertical or horizontal translations. There's 2 reflections. Now I did show you the x one, but we can also do it across the y-axis. In a translation or a reflection, the graph retains the same size and shape. So when we do translations, really the size and shape didn't change. The remaining ones are called your compressions or stretches. That's when the size and shape does change. Okay, so these transformations can be in a vertical or horizontal direction, but the size and shape of the graph will change. Additional problems. Okay, so let's look at a cube. If we take f of x equals x cubed, we want to write a new function g of x based on the following transformations. If we do horizontal shift left 5 units, we get g of x. Well, we're horizontal shift. If you remember, the horizontal shift actually changes the x part. So we should realize that we're not adding or subtracting anything to that x part, but we're going left 5. Left 5 is a negative, so think opposite. This is x plus 5. Okay. 2. If we go reflection across the x-axis, we immediately know that that has to be a negative. Vertical shift down, and that's it. So we haven't changed the x part, so we'll keep it as an x cubed, but we did go down, so the down represented by a -2. And the last one, vertical compression, means we're multiplying something to this g of x. So g of x would be 0.25, and we're multiplying to that cubed. It's a horizontal shift, so that means we're changing inside here the cubed. We're not adding or subtracting. We're going to right 8 units, which is positive side, so the opposite is x minus 8. Last part for 4, 5, 6, 7, and 8. Kind of a self-check quiz. if 2, -7 is a point on y equals f of x graph, then I want you to state the corresponding point on the new function. So it starts at 2, -7, and then I want you to tell me, okay, where's the new point after the shift? Okay, but state the transformations along. So hit pause. I'll see you back in a... I guess I'll talk to you back in a second. I'll talk to you back in a second. I'll talk to you back in a second. Welcome back. Alright, let's check. So there's the first three. So for instance, we don't know what the function is, but we do know that we subtracted 3 on the outside of the function. So it goes vertical down 3, which means that if we started at 2, -7, it doesn't shift the x, it just goes down. So if we're at -7, we end up at -10. Now, if we actually change the function part of the x and we're adding 6, here think opposite. What makes that 0? -6. So therefore we're going to go horizontal left 6. So if we start at 2, let me draw just a quick graph. So if we're starting here at 2 and we have to go left 6, 1, 2, 3, 4, 5, 6, we are now at -4. Hence the point, -4, -7. And the last one, if you notice, we are going... we're adding a -3 and then we're multiplying by 5. So the multiplying by 5 means it's a stretch by 5. We're going to go down by -3. So take our point, 2, -7. If we multiply the -7 by 5, we get -35. So if we're here, and now I go down -3, that takes the -35 to -38. Okay, now 7, we're just taking each of the points, find a couple points that represent the graph. Here's one there, there's one there, there's one there, there's one there. What's happening to those points? Well, if you notice this -2, think of it as the opposite. So -2 makes that 0. So they're going to go left 2 and down 3. So we say left 2, down 3. So take each point. I'll use my little red pen. We're going to go left 2. So start at this one. This one becomes 1, 2. 1, 2, 3. Now we're down here. Okay, if I go to the next point, we're now there. If I go to this point, the third one, we're now there. And then the last one on the far right, 1, 2, 1, 2, 3. We're there. If we connect the dots, we have the new graph. Little tricky on the last one, 8. If you notice, it's just a stretch by 2. So take each point value, y, multiply by 2. So this y value first is a -2. So -2 times 2 means -4. So we're going to go down, instead of -2, we're going to go down to -4. Okay, the next point is at 3. So 3 times 2 is 6. So we have to go up to 1, 2, 3, 4, 5, 6, way up here. This one's on the 0, so there is no up or down, so it stays as 0. And then the far right one goes up from 2 to 4. 2 times 2 is 4. So if we connect the dots, there's our new graph. Congratulations! Remember, do your best, forget the rest. Bye for now, as you stare at the blank screen. Have a great day.